Hello everybody, this is Ramblings of a Sysadmin. I'm Gary Williams, and in this I have a cup of tea, I've got my lab, and what I do is I ramble about a particular topic. So today I want to ramble on a little bit about Docker. I want to talk a little bit about why Docker can be really good and why it can be a right pain in the neck at times. So I hope you enjoy. The first part of this video, I just want to talk a little bit about Docker itself. What I need to do is install Docker. And what I'm using is the Community Edition. Now, this Community Edition will be fine for most people's needs. It's the entire Docker engine. You don't get the full commercial support, but for the most part, you don't really need it. There are Docker forums and plenty of other places where you can go and ask about Docker. So once that's installed, we enable Docker and start it. That's literally all there is to installing Docker. It is super easy. I run the command docker images, I've got no images. But what this tells me is that Docker is up and running, the commands are working, everything there is good. The other thing that we need is we do need to get the status of the firewall to make sure the firewall is up and running. Docker uses the firewall basically as NAT. It passes data from the outside of the Docker engine into the Docker container itself, and I'll show you how that works in a second. Now this does actually get rid of my nice green background for the text, so sorry if you see color changes. It's something I was playing around with on this machine. I just find green a little bit easier on the eyes. So there we go. There's a bunch of command failures that I'm not going to worry too much about. This is probably from me testing earlier today. So, okay, we've got Docker up and running. We've got the engine there. Everything there is working. In Docker, everything comes from an image. Now, we create an image by creating a Docker file, and I've got one here. You may realize that some of the directives in this Docker file are a little bit old school. I don't think label is really used anymore, especially for things around the vendor, but it's in there, it's still supported. So what this does is it pulls down the latest CentOS Docker image. It puts my email address as the maintainer, puts the vendor as CentOS, runs a yum update, and then cleans the yum repos, installs HTTPD, yum cleaner. Actually, to be honest, the update should be after that because we're installing something, we should patch it, but for a demo, it's fine. We then expose ports 80 and 443, and then we copy over some files. Now, I've made some changes to the default Apache background in this because when I was testing this out, I got so sick of the default Apache image, I wanted something different. It was also a good test run for doing some stuff with Docker. Now, what I can do from this is I can actually build this. I do a docker build -t fallout. I can type it. We'll see what it's called fallout shortly. Dot. Now, what this will do is it will look for a Docker file in this area and it will, or in this directory, and it will give it the tag of fallout. So I'll cut this because it can take a few minutes. Great, so that's complete and there's no issues or problems. It's gone through and it's built everything. What you'll notice is it uses steps. So step 9, for example, copies this index.html to a location inside the image itself. Step 10 does a copy, step 11 does a copy. The best way to think about this is these are effectively layers. When you're building a Docker image, you've got the base layer, which is the CentOS or whatever operating system that you're using. Then on top of that, you are building these little elements. You're building the exposure of the port. You're building the copy of the various files. And these all go on top and they result in the creation of the image itself. If I do Docker images, what you'll see is there's actually 2 images. We've got Fallout and we've got CentOS. Now, CentOS was created 6 months ago, and that's the CentOS image that's held at the Docker repository. Or rather, it's the Docker image for that CentOS have provided. Now, Fallout is the one that I've created, and that's the one I want to run. So I will do docker run -d -p 80 Fallout. What this command does is it will run the image I'm telling it to run, which is this Fallout image, and it will say port 80 from the outside world translate into port 80 inside the Docker image itself. We can't use anything other than port 80 for the Docker image. I don't have certs on this because it's just a test one. And port 80 is one of the ports they're exposing here. I go off and run that. One of the irritating things about Docker is it doesn't give you very much good information. It just gives you these long strings of numbers. If I do a docker ps-8, we can see this is actually up and running. Now, this is unfortunately slightly truncated, but what you can see here is this is the name. The name matches part of this string here. The image it's based on is this Fallout image. The command it's running is the Apache run command. You'll notice here it's running in the foreground. A container effectively has to have something running in the foreground, process 0 I think it's called. Otherwise what will happen is the container will run and close. So there's no, whilst I'm detaching the container with that docker run -d, I'm detaching the container from grabbing the foreground of my machine itself. But inside the container, I have to grab the foreground of that container. So it sounds a bit confusing, but effectively the container is a bit like a virtual machine. But in this case, you want to have something grabbing that foreground so that it can't be interrupted. If it does get interrupted, then it will just close down the container. And what you'll have is this weird situation where the container runs and then stops and you won't really be sure why. There are ways to fix that, but that's for another video. What you'll also see, which is a bit more interesting, is ports. So ports shows this IP 0000, which is the entire world, 80 to 80 over TCP. And all that's doing is that's put a rule in the firewall to say anything connecting on port 80 to this machine will be passed through to that container. Now, this is a bit boring because it's just text, so let me show you what it actually looks like. And this is it, and this is why I call it Fallout, because this image is actually from Fallout, and I actually prefer this to the really quite dull and boring default Apache image that I've seen about 1.5 million times. So that's great. We have a really boring web page. So what? What can we do with it? Well, this is where Docker gets quite interesting. Let me just jump. Actually, let me show you something on here. So if I pick a random port, I don't know, 9246, and I go to connect, it's going to time out because there's nothing listening on this port. You can see it trying to connect up here, and it's trying and it's trying. Eventually, it times out. Makes sense. There's nothing on 9246. Let me switch back to Docker. So now I can demonstrate the real power of Docker. What I've got up and running is a really simple web page. You know, it's only got that Fallout logo in there just for demonstration purposes. But let's say that this was a production machine and it had a lot more in that container. You know, it's quite an important container. What we can do is we can spin up other copies. Or if we're doing something in testing, we could try out a new container on a different port just to see if things work before swapping it in. So let me give you an example of that. Now, I just tried to connect to the Docker server on port 9246. It didn't work. What I can do, though, is I can do docker run -d -p 924680 Fallout. And that will spin up another container. Now, what you'll see here, and I wish this wasn't wrapping, but hopefully you can see it. It shows the created 4 seconds ago, up 2 seconds. We have this container called Frosty Hayrovsky. I do love these names it creates, but it's this ID here, 158 blah 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 blah. And what this container is doing is it's soliciting connections from any IP address on port 9246 through to port 80. So if I jump back to my web browser, hit reload, boom, I'm in. I've not had to do anything with Apache vhosts. I've not had to do anything with Apache at all. I just spun up a container. And we can do this time and time again. Jumping back. 47. 48. 49. It doesn't matter. And the beauty about this is it doesn't really take up any additional disk space, because all we're doing is we're pointing to an image already exists, it's already downloaded. We're just spinning up these endpoints. Now, the true power of Docker, I'll just switch back to my browser and just quickly demonstrate this. And you can see there, it's all up and running, 9247, 9248. Now, the real power of Docker here is we don't have to install anything. Everything's already baked into the image. We've not got to go off and find scripts or keys to access things. It's all there in that image. We just have to run it. So obviously, running a container like this on different ports isn't really going to help you if you need to scale out because you need more CPU. But this is where something I'm going to show you in a future video will come in handy. Tools like serverless with Fargate and all of that kind of stuff. And this is really what DevOps movements are all about today. This whole environment where you're moving towards a containerized approach so that you don't have to worry about where all of your scripts and other bits and pieces are. You just deploy an image from a repository, run a container, you're up and running. And if you're using tools like Amazon AWS Fargate or whatever the Azure equivalent is, I'm sure there is one, you've got this ability to run these containers on their hardware using their CPU and their resources. And you don't have to change anything. You don't have to create a machine and pay for that machine's time while you build it and test it. You literally deploy the container, you are done. And the nice thing about it, let me just jump back to my app here. Nice thing about it is if I need to do any upgrades on this, like say there's some patches, all I have to do is rerun this. If there's no changes to my application, all I have to do is rerun the Docker file, create a new container. And you've seen how easy it is for me to deploy a container. So all I have to do is stop the existing container, deploy the new container. Downtime is 2 or 3 seconds. Now, in some cases, even a downtime of 2 or 3 seconds may well be too much. So this is where all the tools like Kubernetes come in. Because what Kubernetes will do is it will do a upgrade and replacement for you in such a way it uses internal load balancer tools and internal DNS and something that I will go through in a future video. What it will do is it will take the containers down in a rolling upgrade fashion. So you don't even have any downtime there. It's all transparent. Now, that's not strictly true. There can potentially be issues with SSL if you're not propagating the SSL IDs across all of your containers. That's a whole other story. But what Docker does, the real power of Docker, is that it simply lets you have this image that has everything pre-baked into it, so you can just run it and know you're going to get a working application at the end of it without having to pull together 1,000,001 different files, scripts and other bits and pieces. It's all there, it's all in that image, and it's all ready to go. So for those of you who haven't used Docker or are possibly new to Docker, or just curious about it, I really hope this has served as a good introduction. What I've shown you here is really the tip of a very big iceberg, the amount of stuff that you can do with Docker. Even I probably know 10-15% of it. I've just done some very basic containers, but the power is there and there is a hell of a lot more you can do. So what I do want to do is develop this over the course of a few videos. If anyone's got any questions, any comments, love to hear it. If this has been useful, please drop a like and a thumbs up. If it hasn't been useful, then please do a thumbs down, but please tell me why. I'd love to know what I can do to make this better. And I hope that's been interesting. Thanks very much for your time.